Hello everyone, welcome back to ECE111 classes. So today we are going to discuss another theorem for simplification of circuits and determining its solution easily. So the theorem is Reciprocity Theorem. So in Reciprocity Theorem, it states that in any linear bilateral network with a single independent voltage or current source at branch X, the current or voltage response at branch Y will remain same if the position of source and responses are interchanged. That means if we consider a circuit at branch X, this is suppose your branch X, here we have a source, it can be either voltage source or a current source, and the response at branch Y is IL, that is current obtained or voltage obtained, will remain same if we interchange the source and the response. That means we will bring from branch Y the response to branch X, and we will be sending the source from branch X to branch Y, then the response remains the same. So let us consider a small circuit and then explain. Suppose we are determining current in this circuit. So as we are considering voltage source, so it should be current. So this is IL. So we are measuring current IL across this branch, across this RL. So it will remain same if we replace the source and the response. So that means we will be interchanging the source and response. So in this, the direction of current is downward, so accordingly the voltage source direction should be like this, then only we'll be having the current direction downward. So this will become Vs, and this IL means we'll be putting an emitter here, so the position of the emitter and the source will be interchanged. That means the emitter will come here. It means we'll be having the current in this direction. So in case of what, this is in branch X, this is the response in branch Y. So what we have done, we have interchanged the source and the response. So in this case, if suppose we are getting IL as 2 milliampere, in the second case also, here also we are going to get IL dash as 2 milliampere. So this is reciprocity theorem. So using this, suppose if our circuit is slightly difficult to solve, and it has a single source and satisfying this condition of single independent source only, then what we can do, we can interchange the position of the source and the response. And obviously we will be doing that only when if our calculation or the procedure becomes simpler. So this is what reciprocity theorem is. And one thing what we should know, and that is most important point, and that should not be, there should not be any doubt or mistake at that point, that is, whenever we are considering a voltage source, the response should be current. Whenever we are using a current source, the response should be voltage. Okay, so this is the main condition that we should remember. So suppose a question is coming in examination that determine or verify the reciprocity theorem in this circuit. So if it is not mentioned, then suppose the our source is voltage source, then we have to determine the current across the load, and if our source is current source, then we have to determine the voltage across the load resistance. Okay, so using Thevenin theorem or Norton theorem or superposition theorem, as we can minimize the calculations or make our circuit simpler. Similarly, reciprocity theorem also helps us to make our circuit solutions simpler. And for solving these circuits, we can use any of the methods. Like we can use mesh analysis, we can use node analysis, right? So let us consider the circuit in a simulation. So as you can see here, we have a 20 volt, and this is our circuit consisting of 1 kilo ohm resistors, all are 1 kilo ohm. Now this is our load, suppose this is our RL. So now what will happen if we interchange the position, then for this RL we will determine the current in this branch. So in this branch we will be having the source, so this 20 volt will appear here. So this is the corresponding reciprocity circuit, and the current should be determined in this branch, so that is why it is short circuit. Okay, so now if we run this and determine the current, then as you can see here, the current is 5 milliampere, and in the same branch in the second circuit we are having 5 milliampere. That means reciprocity theorem is valid, right? So this is for voltage source and current response. Now similarly we can also check for current sources where we have voltage as our response. So let us consider this circuit. Okay, so let's see the circuit. So as you can see here, this is our 2 ampere current source, and we have 10 ohm resistors, and this is the 1 kilo ohm resistor. Now what we have to do, we are determining the voltage across this resistance. This is our load resistance. So if this is the load resistance, whenever we are putting the voltmeter, it will be in parallel, so the current source will be coming here as parallel, and the voltmeter will go here. Now if the current source will come here, then this will be the circuit, right? And next, if you want to find out the direction, so if you are considering voltage in this branch, then this will be positive on the upper terminal, lower terminal will be negative. So that is why current direction will be in the upward direction. So 2 ampere will appear here. Now if we have to put a voltmeter here, then obviously this terminal will be open. So if this terminal is open, then whatever is voltage is appearing, that will appear across this resistance. So instead of determining it here and putting open circuit doesn't work in case of PSpice software. So what we can do, we can remove this, we can determine the voltage in this branch. So this will be our circuit. Okay, so now if we run this and determine the voltage, so this is the voltage across this branch, that is 6.623, and after putting it in the reciprocity circuit, we are getting the same amount of voltage, 6.623 volts, right? So here also we have proved the reciprocity theorem. So this is very much simpler to use, and we can use this for solving any circuit, and the condition should be, it should be linear and bilateral, first condition. Second condition should be, it should contain a single independent source. So that means we cannot apply reciprocity theorem in circuits which is having dependent sources. Okay, so that will be all. Thank you for joining.